Flack math! Give me some math and I'll give you some flack. Flack math!
All right, so let's just go through it. Number one. What property of multiplication states that the order in which two numbers are multiplied does not affect the product? Do you guys know? So it's commutative. So you could just say commutative. You could say commutative property of multiplication. There's another property that we talked about, associative. And associative just, if you have three or more things you're multiplying, it doesn't matter what you put the parentheses around. So it's not different order, it's just what you're putting the parentheses, how you're grouping them, okay? Everybody good with number one? Thumbs up? Okay. All right, number two, the diameter of a circle is 10 yards. Find the area of the circle, okay? So I'm just gonna take some notes down here and just draw a circle. You could probably do that really cool, like with shapes over here. Oh, I'm gonna try it. I'm just gonna do it. Look at that, isn't that pretty? Go back to drawing. So the diameter, remember, is all the way across. Does it say diameter? Yeah, the diameter is all the way across. So that is 10 yards. But on your test, it might give you the radius. So if it gives you the radius, then make sure if you need the diameter, you just need to double it, right? So if the diameter is 10, then the radius is 5, so 5 yards. So we're trying to find the area and the circumference. So area equals pi r squared. Okay, so if we plug in our numbers, it's just pi times 5 squared, or in other words, 25 pi, right? You can leave it like that, or I think if you, what is it, 78 point something? If you multiply it by 3.14, you can do that. You'll just need the little curvy equal sign, which means approximately. Does it? Let me just figure that out real quick here. Yeah, 78.5, right? Shoot, am I recording? I am recording, right? I am recording. Yeah, 78.5. And don't forget your yards, so square yards. Square yards. All right, now circumference is just pi times diameter. So C equals pi d. So they already gave you the diameter, so you could just say 10 pi yards. Stop it. Okay, or if you wanted to multiply by 3.14, that's easy. Just move the decimal, 31.4-ish yards. And there it is. Everybody good with number two? Okay. All right, so number three, use 3 unit multipliers to convert 1,520 meters to feet. All right, you can do this however you want, but if you use unit multipliers, I'm going to give you 1 point, at least 1 point extra credit, okay? So first step to unit multipliers, you might want to write these down if you don't have them already. First step is to write the first measurement as a fraction. And most of the time, it's just putting it over 1. So 1520 meters over 1, okay? All right, and then you have to choose, step two, you have to choose a unit multiplier that will cross cancel that first label, okay? So we're going from, remember we have to go across the bridge. So these are our centimeters over here. So here's our meters. We have to get the inches, and then we got the feet. So the only bridge is right here. We got to cross that bridge. So we have to go to the centimeters first. Okay, so to convert meters to centimeters, you multiply by 100 centimeters over 1 meter. Okay, and then you can cancel the meters. So to get from centimeters to meters or meters to centimeter, you have to use a unit multiplier that involves centimeters and meters. Okay, and unit multipliers are, remember, the same thing over the same thing. So 100 centimeters over 1 meter, or 1 meter over 100 centimeters. This one, you have to choose this one because that'll cross cancel the meters. The other way to look at it is what's on top is where you're headed. What's on bottom is what you're trying to get away from. Okay. All right, next, we're not there yet. We have to cross the bridge. So to cross, go from centimeters to inches. Remember, centimeters needs to be on the bottom and inches needs to be on the top. So 2.54. So you will memorize this eventually, but if you need to write that down for reference to know how many centimeters are in an inch, then you can do that. All right, now our centimeters cancel, but we're still not there. We have to get to feet. Okay, so multiply by 1 foot over 12 inches because we're wanting to get to feet and get away from the inches. Okay, so here's what we're left with. If you multiply fractions, you just multiply across. So 1520 times 100 times 1 times foot. Okay, so the feet goes on top, and then you're left with what's on the bottom, 2.54 times 12. Okay, you can do all that math if you want, or you can just leave it right there. That tells me that you know how to do it and you don't have to do the math there, okay? If you do it that way, you get some extra credit. Now, usually, and I can't promise anything, but usually the test is gonna look just like this, and it's actually gonna be meters and feet, but you're probably gonna go from feet to meters. So if that's the case, everything's flipped upside down. Okay, but I can't guarantee. I haven't looked at it lately, but usually it's the same units, like meters and feet. So it's either going from meters to feet or feet to meters. Okay, now you can do it your own way, convert it however you want, but you just need to use that 2.54 conversion in there. Okay, don't use like 39 inches-ish is a meter and things like that. Convert it to centimeters first, and then to inches, and then to feet. Okay? Questions with that? All right, good. Number 4, find the number that is 27 greater than twice the opposite of itself. Okay, this is a 2-part problem. You need to translate first and then solve. Okay? So if you translate incorrectly, but you solve that incorrect equation correctly, then I'll still give you partial credit, okay? If you translate correctly and then don't solve it correctly, I'll still give you partial credit. So find the number that is 27 greater than, okay? So how do you say 27 greater than twice the opposite of itself? Well, first of all, find a number, that's n, right? So that is, how do you say 27 greater than? Well, that's addition. Twice the opposite of itself. So twice 2 times parenthesis negative n, or if I just bring that negative sign out, then it'll just be negative 2n. So n just equals, n equals 27 plus, oh, this is bad here, negative 2n. Okay, so now I've got an equation. Now I'm going to follow the steps to the equation. First step is to simplify both sides separately. Yeah, there's no parentheses and there's no like terms on the separate sides. So now the next step is to get rid of the smaller variable term. Well, n and negative 2n. So I'm going to get rid of negative 2n by adding its opposite, plus 2n. Whatever you do to one side, do to the other. So then I've got 3n on this side, and then a 27 on this side. Last step to solving, so there's no constant on the variable side, so we can skip step 3. Last step is to divide by a variable's coefficient, because a coefficient multiplies by the variable. So n equals 9. Is that what you guys got? All right, if not, then make sure you go over it again and follow those steps to the equations. If you want to keep those steps handy when you take your test, that's fine for now. So you should have written those down, but if not, you can look back at a previous video. I'd like to write them here, but I want to make sure we get through all of our questions. Okay, number 5. Let's look at number 5. Write 420 as a product of prime numbers. Okay, this is one of those problems where you can do the factor tree, or you can do the cake method. Let's just do the factor tree. So 420, what times what equals 420? Easiest thing, it ends in 0, so let's break it. I think when you do factor tree, some of you guys like to just divide by 2, divide by 2. That makes it harder math. So just see what the biggest thing that goes in there is. Okay, well, 10 times 42 will break it up into some easy numbers there. And then 10 is 2 times 5. 42 is 7 times 6. And then 6 can be, so once you get a prime number, I would circle it so you don't have to do, that's the fruit of the tree, and you can't bring branches out of a fruit. So this is 2 times 3. All right, so make sure you show your work, because sometimes like you might forget one of these. So I'm going to use exponents. There's 2 2's being multiplied, so 2 squared times, there's just 1 3 being multiplied, 1 5, and 1 7. All right, make sure you check your work too. So let's see, this is 2 squared is 4, 5 is 20 times 21, 420. Okay, works. So make sure all these numbers are prime and it multiplies to get 420. All right, that's not, if that happens, then there's no way you can get this wrong. Okay, number 6, 2 2/3 of what number is 13? So first step, translate. 2 2/3. Well, remember, we don't like mixed numbers, so we're going to change this to improper fraction. 2 2/3 is what? 3 times 2 is 6, plus 2 is 8/3. And how do you say of in math? That is multiply. And then what number? How do you say what number? Let's use a variable n. Is equals, and 13 is 13. All right. So this is an equation, and there's only one step. You just have a coefficient. So dividing by a fraction, we're going to copy dot flop, right? 13 divided by 8/3. Well, that's just 13 over 1 times 3/8, copy dot flop. Nothing cancels, so you're left with 39/8. Okay, if you want to change it to an improper or a mixed number, you can. What is that? 4 7/8 or something. Is that what you guys got? Okay, cool. All right, moving on to number 7. So if f of x, so this is functional notation, so this might be confusing to some of you. If f of x, the function of x, this is not f times x, okay? If the function of x is to multiply it by 7 and then subtract it from a -5, then what's the function of -2? So all we're doing is replacing -2 for f of x. So f of -2, I'm going to do the same thing that function did with x. So equals, oops, I'm doing it on the wrong side. So f of -2 is -5 minus 7 times -2. Okay, let's do order of operations here. Order of operations. So first of all, here's what I'm going to suggest. A lot of people get confused on this left side, so you can just ignore it, okay? This is just like our plug and chug problems. We just substitute -2 in for x and then chug it out, right? So this is -5 minus -14, okay? So if you mess it up, it's probably going to be with this positive or negative thing here. So let's chicken scratch that. That's confusing. So now we've got a -5 added to a positive 14 to give us a positive 9. Okay? Does that feel all right? Is that right? Is that what you guys got? Okay, sweet. All right, number 8, simplify. So this is one of those weird ones. Well, first of all, what do you do with negative exponents? Remember, negative exponents have nothing to do with whether they're positive or negative, okay? Negative exponent means throw it downstairs and square it. So if it's a -2 exponent, throw it downstairs with the positive exponent. Okay, so this is going to be negative is left on top, because remember this exponent only applies to the 3, so that negative is not touched. So then this 3 comes downstairs with a positive exponent. Okay, but there's nothing left on top, so you need something on top, so throw a 1 there. So you're just inverting 3. So 3 inverted is just 1/3, but so now you can flush that out. That negative, you can still have that negative there, and then 3 squared is 9, so we just have -1/9, and that's for A. So B, if it's on the bottom with a negative exponent, then put it on top with the positive exponent. And so remember, so when that goes on top, you've got a, let's just rewrite it here. So this guy goes on top. So remember, the negative is not affected. So then we have a 3 to the positive 2 on top with a negative sign on the bottom. Well, if everything goes in just the negative, so just put that negative. So now we've got 9 divided by -1. So that's just -9. Okay, so both of these, that negative was not included in the exponent. So your answer is probably going to be negative. I'm not sure what the test is like, but if there's a parenthesis around that -3, then you have to square the -3, which becomes a positive 9. Okay, does that feel okay, doable? All right, number 9. Number 9 is factor the greatest common factor. Okay, this is what we talked about recently on, I think it was last Tuesday, but you're not just looking for the greatest common factor, you're factoring the greatest common factor. So you not only have to find the greatest common factor, but you have to pull it out. So remember, it's like going shopping to these 3 stores and pull the greatest common factor off of the shelves, okay? So first, numerically, the biggest number that goes into all 3 of those, 3, 6, 9, is just 3. So I'm going to take a 3 out. Okay, and then the greatest common factor with the variables, with the literal factors, is you're just looking for the smallest exponent of each letter. Okay, so a squared, a cubed, a squared. So a squared, b cubed, b squared, b squared. So b squared, c squared, c to the 4th, c to the 4th. So c squared. Okay, so there's the greatest common factor. All right, now the trick is, now we have to divide it out of each one. So this is like the reverse distributive property. So if it helps, you can write your parentheses like that, okay? So what do you have to multiply by the greatest common factor to get 3a squared, b cubed, c squared? You don't have to multiply 3 by anything. You don't have to multiply a squared by anything, but b squared times b equals b cubed. Okay, so that's what's left on the shelf once you buy the b squareds. There's one b left. C squared, you don't have to do anything, so you could just leave b alone, all right? All right, next, minus. How do you change the 3 to a 6? You have to multiply by 2. How do you change a squared to a cubed? You have to multiply by a. How do you change b squared to b squared? Multiply by 1, or just don't put anything, because 2a times 1 is just 2a. And then how do you change c squared to c to the 4th? You need to multiply by another c squared. Okay? All right, and then the last one, plus 3 times 3 is 9. Remember, these are big numbers, so you're not subtracting exponents or adding exponents. When you multiply variables, you add their exponents or subtract the exponents. So when you divide out a 3 out of 9, it's not 6, right? It's easy to do that because you're in this multiplying and dividing exponent mode, and you got to get out of that, okay? All right, so 3, oops, what happened? Okay. So how do you change an a squared to an a squared? You don't. How do you change a b squared to b cubed? Or b squared to b squared? You don't. How do you change a c squared to c to the 4th? Just another c squared. Okay? So if you find the greatest common factor, that's great. That's half credit. If you give me the whole problem, that's the other half. Okay? Does that feel doable? All right, that's good news. All right, number 10, simplify, factor if necessary. That's a nice little hint. So we're going to factor out that top. So we're going to pull a 5 out of that. And we have an x squared plus, we can pull more than a 5 out. Did you guys catch that? So what's the greatest common factor of 5x squared and 5x? Well, numerically it's 5, but you can take an x out. That's what we just did in the last problem. The smallest exponent of x is x to the 1st, or just x. So take it out. What are you left with? I'm left with just an x plus, take a 5x out of 5x. You're dividing, remember. You're just left with 1. And that's all over 5x. So now you can cancel these. Please don't cancel the 5x's right there. Don't do that. Remember, every time that happens, a kitten somewhere in the world dies. Okay? So don't. For the love of kittens, don't do that. Jaycia, I'm sorry. That startled you. Okay, so now you can, because you can't cancel something that's not being multiplied then divided. Remember, this is being multiplied. There's nothing being multiplied. It's being added. So you can't, division does not cancel with addition. It only cancels with multiplication. Well, now down here, it's being multiplied. So 5x times something divided by 5x. Now you can cancel those, and you're left with x plus 1. Okay? The other way to do this is 2 division problems. So remember, the alternative way here is to just do 2 division problems. So you could separate 5x squared over 5x plus 5x over 5x. And then you just reduce these. When you divide 5x squared by 5x, you get x. 5x divided by 5x, that's 1. Okay, so there's 2 ways to do this. This bottom way is kind of like the distributive property of division. You're going to divide both of those things by 5x, not just one of them. Okay? All right. Can you guys do one of those ways? Feel okay about that? Okay, awesome. All right, I'm going to scroll down. Okay, here we go. Can you see that number 11? So we're just going to evaluate. We're just going to plug in -1 for m. So remember, when you're plugging in negative values, it's better to use parentheses. So negative 1 squared minus parenthesis negative 1 to the third minus parenthesis negative 1 to the fourth. Okay, evaluate each one of these. So we're going to do exponents first before we do subtraction. So negative 1 parenthesis squared, you're squaring all of negative 1, so negative 1 times itself is positive 1. All right, but negative 1 to the third is negative 1 times negative 1 times negative 1. When you multiply 3 negatives, it stays negative. So then it's just negative 1. And then here's another even exponent. Even exponents cancel out the negatives. So negative 1 multiplied by itself 4 times. 4 negatives equal a positive. So 1 times 1 times 1 times 1 is just 1. All right, now I'm going to chicken scratch to make this easier. Plus positive and plus negative. All right, so let's see. These cancel. 1 and negative 1 cancel, and then I'm just left with 1. Okay, does that feel all right? All right, number 12. Oh, is there a question? Or is that a thumbs up?
Nathan has a question.
All right, Nathan. You might need to come forward so I can hear you.
Never mind.
Okay.
Go ahead.
All right, number 12. Simplify by adding like terms. Okay, well, it's hard to tell that they're like terms because they're not cleaned up. So let's clean up each of these terms first. This one looks pretty good. I'm going to leave it as a negative exponent for now. Because really you're just adding the exponents of, so I can clean that up to, let's see, add the x's together and you get 5x, or you get x to the fourth, right? And then add the y's together and you get y to the negative third. So far, that's the same term as the first one. So we have 2 like terms so far, okay? Now look at the next one. You can add the exponents of the x's together and you get x to the fourth. And then add the y exponents and you get y to the negative third. All right, there's another one. Cool. All right, last one. Minus 2. Add the exponents of the x's. 3 plus, when there's no exponent, remember it's just 1. So you got negative 2x to the fourth. And then y to the 1 plus negative 4 is negative 3. Well, look at that. All of them are like terms. So now you can just add them together. So you get 6 plus 1 minus 2. So you end up with 5. X to the fourth, y to the negative thirds. Now, a common mistake here is to add the exponents again when you combine the like terms. No. When you're combining the like terms, you don't touch the variables or their exponents. Only when you multiply them. See, we added the exponents here because we multiplied them together. But when you add like terms, it's kind of like saying 5 fish plus 2 fish is 7 fish. You know, it's not 7 fish or fish squared. All right. So when you're adding things together, don't touch the label or the variables. All right, number 12, seem okay? That's a little bit more advanced, but that's okay. All right, number 13. I'm going to do a different color here. I'm going to do my rainbows. So basically, I'm going to multiply these 2 things together. This is just 2 multiplication problems, all right? So just squish all those together. So maybe I'll do this step first, where I'm just squishing it together. Times a to the negative 1 b minus, all right, now do this multiplication, 2a cubed b to the 4th times 3a to the negative 2b squared. Okay, let's clean that up. So I get 2, and then add the exponents of the a's, and you get a squared. Add the exponents of the b's. There's no exponent there, so it's 1. 4 plus 1 is 5. Minus, okay, multiply the big numbers together, you get 6. Add the exponents of the a's, and you just get 1, or you can just leave it a. Add the exponents of the b's. 4 plus 2 is 6. And there it is. Is that what you guys got? Okay, cool.
Nathan has a question.
Yes, Nathan.
For number 12, aren't they all?
You're going to have to come up, dude. Sorry.
For number,
Number 12, what?
for number 12, aren't they all the same because isn't 4 have the same exponents as all the other ones? Because the final answer is 5x4 y negative 3. But
Yep. They're all, that's why we were able to combine them together.
yeah, but 6, what about the 4x y3 negative 3 at the very
Here,
beginning?
come closer.
Where is the 4? Oh, I didn't even see that one. So that's the first one. Sorry. So yeah, so just add 4 and then we get 9 there. Good job, Nathan. You caught it.
I thought it was subtraction.
So I see how I was just adding this right here instead of, I forgot about the 4 there. Okay, good catch. All right, does that make sense? Good job. All right, number 14. So this is just following the steps of equations. So the first step to solving equations is to simplify both sides separately. So what we have to do is we need to combine like terms. So these two need to be combined, okay? So when I combine those like terms, I just go 0.06 minus 0.02, that's 0.04 x plus 0.24 equals 0.36. Okay. Second step to solving equations, if you have variables on both sides, you don't. So third step is to get rid of the constant on the variable side. That's just 0.24. So subtract 0.24, whatever you do to one side, do to the other. So those cancel, and you're left with 0.04 x equals 0.12. Last step to solving equations is divide by variable's coefficient. So divide by 3, divide by 3. Divide by 0.04, divide by 0.04. Okay, so x equals, if you do that on a calculator or you do it normally, that's just 3. A nice, pretty 3. Is that what you guys got? Okay, cool. All right, scrolling down a little bit, number 15. 15 is right up here on the top. It's just kind of hidden there, but we're going to follow the same steps to solving equations. First step is to simplify both sides. First step to simplifying is to get rid of parentheses. So I see parentheses here. So, and then in the steps to solving equations, it says to get rid of parentheses, you need to distribute. Well, the only thing being distributed is this little subtraction sign. So here's what I'm going to do. So I'm going to chicken scratch, but that negative sign needs to be distributed to both of those. Okay? So here's what my equation looks like. My equation, after I distribute, looks like this. Y plus negative 2y minus negative 1. Okay? Plus 3 equals 2y plus 7. Okay? So now I'm going to just clean this up a little bit. After you get rid of parentheses, you can combine like terms. Well, the y's can be combined to a negative y, right? And then the constants, 1 plus 3 is 4. And then on the other side, we're already cleaned up, no parentheses, no like terms on the other side, so we can leave it like that. So step 2 is if you have variables on both sides, get rid of the smaller one. You do. You've got this negative y and a positive 2y. So which one's smaller? The negative is always smaller than positive. So to get rid of a negative term, you add the positive version of it. So plus 2y, or plus y plus y. So you're left with 4 equals 3y plus 7. All right, next step, solving equations, get rid of the constant term on the variable side. This time the variable side is the right side. So get rid of that 7. So then we're left with 4 minus 7, which is negative 3, equals 3y. All right, last step, divide by variable's coefficient. And you get y equals negative 1. Okay, is that what you guys got? It's a little tricky. Is there a hand up or is that a thumbs up in the back? Thumbs up, okay. All right, so yeah, the biggest mistake is that subtracting the parenthesis, okay? That 1, you're not subtracting a 1, you're subtracting a 1, if that makes sense. So the 1 is already being subtracted in the parentheses, so when you subtract the parentheses, you're subtracting a subtraction. So that's adding a positive. All right, number 16. Improper fractions are dumb, or mixed numbers are dumb, so we're going to change them all to improper fractions first. That's what we're going to do. Negative 1.5 is just negative 3/2 plus 15/4 x equals 43/8. So far, so good? Okay, now that feels better with improper fractions. So first, we're just gonna do the same stuff as we do with solving equations. Everything's simplified. There's no parentheses, no like terms on the same side. So we're gonna get rid of the constant term, which is step 3. We don't even have to do step 2 because there's no variables on both sides. So we're just gonna add a negative 3/2 to both sides. 3/2 is the same thing as 12/8 because we need a common denominator, right? So then we're left with 15/4 x equals 55/8, right? Last step to solving equations, divide by variable's coefficient. Well, this coefficient is 15/4. So dividing by 15/4 is the same thing as multiplying by 4/15. So I'm going to go 55/8 times 4/15. Now there's lots of juicy cross canceling, cross reducing here. So 4 and 8 is 1 and 2. And then a 5 goes into both of these guys, 11 and 3. So your final answer, I don't think I can write over here. Can I write over here? Equals, no, I can't. So what is that? 11/6. That's nice. So x equals 11/6, or you could say 1 and 5/6. I'll take both answers. You guys good with that? It just got fractionated, all right, but still the same rules. All right, number 17. So this is a little complicated. So I'm gonna work up here a little bit and try to clean some of this up. First order of operations is parentheses. Remember, absolute values is a form of parentheses. So I'm gonna do this first. So let's see, that's negative 27 minus 9, right? So if I'm cubing a -3, -3 times -3 times -3 is -27. But then I throw a negative in front of that, and that'll eventually become positive, but let's leave it like that. And then minus 3 squared. 3 squared is 9. Okay, so the absolute value of that is going to be positive 27, right? Plus positive 27 minus 9, which is 18. So this is the absolute value of 18, which doesn't look like that. Okay, so here's my problem. I'm going to just write it out here now. So I've got -3 squared minus parenthesis -2 cubed minus 2 to the 4th minus, what's the absolute value of 18? Just 18. If that was a -18, then we just make it positive. But if you end up with the positive in the absolute value, just leave it alone. Okay, so now we do exponents next. So let's do that. Negative, remember you don't touch the negative on the -3 there, so we're just going to leave it negative. And then 3 squared is 9. We're just doing these exponents. Then minus -2 cubed is -8. When you cube it, a negative, it stays negative. When it's an odd exponent, remember, it stays negative. When it's an even exponent, it cancels to positive. Okay, and then minus 2 to the 4th is 16, not 8. Don't make that mistake. Minus 18. All right, I'm going to clean this up a little bit by chicken scratching. Plus positive 8 plus -16 plus -18. So I only have one positive fighting against this army of negatives that's going to combine into one big army. -25, -18 is negative, what is that, 43 plus 8 equals -35. Is that what you guys got? Cool. JC, thumbs up. Nice. All right, 3 more. Can we do it? I think so. So hopefully you can see these numbers, but I'm going to write them out here just in case you can't. That's a 2 right there. This is a 3, and that's a 4. So the only way you can solve this or find the area of the shaded portion is find the area of the circle and then subtract this little trapezoid thingy here. Okay, well, you know how to do both of those. So how do you find the area of a circle? Pi r squared. Well, it doesn't label it, but it gives us the radius of the circle. It's 3. Okay, so area equals pi r squared minus, well, let's calculate this right now. Okay, so that's a 6 rectangle. And then that's 4. Did I say that? That's 4 all the way across. So that means if that's 2 and this is 4, then that's a 2 by 3 triangle. Okay, so 2 by 3 triangle, 2 times base times height divided by 2. So that's 3. So that area of the triangle is 3. So 6 plus 3 is 9. So we're going to subtract 9 from whatever pi r squared is. Well, r is 3. So this is 9 pi minus 9. And you can leave it like that, but don't forget your label. When you have to label it, unfortunately, you got to put parentheses around it. And then it's in feet. So this is square feet. If you wanted to multiply it out, you can. whatever 3 times pi is. So 9 times 3.14. Okay, is 28.26 minus 9 is 19.26. So you could say, or roughly 19.26. Is that what you guys got? Who multiplied it out? Does that look good? Okay, good. All right, number 19, find the perimeter. Okay, this is a real quick and easy one because it's just add all the horizontal sides and add all the vertical sides. We don't need to know the details of these dimensions here. We don't need to know these. We just need to know that these 3 sides have to add up to 7, okay? And then these 3 vertical sides have to add up to 5. So we're going to have 2 7s and 2 5s. So just double the vertical lengths and double the horizontal lengths. So I think your final answer is 24. And then it's, what is it? Centimeters? Can't keep track of all these labels here. Okay, does that make sense? So if you want to guess at these lengths, you can do that. You might guess it wrong, but in the end, you're going to get the right answer because when you're guessing, you're in your mind, you're trying to figure out what's going to add up to 7. So you can add these guessed numbers if you want to guess what those lengths and guess these vertical lengths, and it's not going to hurt you. Okay, but when you do that, you'll realize in your mind, oh, I didn't even have to find those numbers. Okay, and that's okay. All right, so a base of a right prism whose height is 8 inches is shown. Where is this shown? Did I miss that? All right, I'm looking. Can you guys still see this? I'm just going to look at this. Can you guys still see my screen? Is it all gray right now? Okay, scrolling down to the bottom. Yep, I didn't see that. So let's see here. So to find the surface area, oh, this is a big one. Surface area is basically area the top and the bottom, and then the lateral surface area, which is just the perimeter times the height, okay? So let's calculate the lateral surface area first. To find the perimeter, we can do this the same way we did in the last problem. The perimeter of this guy is just 2 12s and then 2 13s, right? Because the 7 plus 6 add up to 13. So 2 12s is 24, 2 13s is 26, so 24 plus 26 is 50. So the perimeter of this guy is 50, all right? And then the area, look at the area. So we still need to find the area of the top and the bottom. So to find the area, let's see, that's a 6 by 4 rectangle, so that's 24, and then a 7 by 12 rectangle, which is 84. So 24 and 84 is 108, okay? So that's the area of that. So let's go back here. Sorry, I don't have it written out. That's not right. Back here. So to find the surface area, it's top plus bottom, and the top and the bottom are the same, plus the lateral surface area, or the lateral area. So what did we say? The top was 108 plus another 108. Plus that lateral area, which the perimeter is just perimeter, it's just perimeter times height, right? So it's just 50 times, what's the height of that prism is 8 inches. So that's 400. So we got 216 plus 400, which is 616. Is that what you guys got? Did you guys get something different? OJC says yes. So that makes me feel better. Okay, so lots of ways for you to mess this up. So don't stress, do your best, you'll be fine. But look over this video again if you have questions. Remember the test, we're gonna start taking it on Thursday in class. So I'm gonna hand it out to you, or not, I'm not going to, but somebody will. And then you just bring your own paper. I would suggest bringing a template like this, or make your own on graph paper, and you'll be fine, okay? Any questions? You're okay?
Yep.
Okay, awesome. Well, Schoology me, message me if you have any questions or anything like that, okay? All right, I'm gonna sign off. Good job, guys. We'll see you soon.